Hello everyone, I'm Hwama from the WorkinProgress project of Keio University in Japan. This time I'll introduce our research proposal to design and implement a smart textile using conductive sequins produced by a 3D printer based on traditional sequin embroidery. Today, smart clothing is becoming more and more popular. Smart textiles are an essential part of the manufacturing process for smart clothing. Most use conductive dyes or using uh, so, conductive sewing thread to create circuits on textiles. Others use elastic conductive materials to alter the structure of textiles. However, in general, the design and representation of these smart textiles are mostly limited to flat surfaces. That limits the space for smart components to be embedded in the textiles and make it more difficult for the fashion design. Sequin embroidery, a traditional embroidery technique, has a wide range of applications in textile manufacturing. By changing the size, shape, color, arrangement, and embroidery method, we can get various types of sequins textiles. It has a semi-dimensional structure, a simple embroidery method, and unique haptics, and also has interesting interactions such as flipping sequins. We can use a 3D printer to produce various conductive sequins to increase the three-dimensional representation of the textiles and provide more possibilities for circuit design and more space for fashion design and explore more ways of interaction. This paper proposed a smart textile with conductive sequins with data input functions produced by 3D printing. Touch input and shape recognition can be achieved by touching, pressing, or flipping the conductive sequins. It can sense and visualize human actions and environmental changes like the natural wind. By adjusting the sequence shape, size, texture, and the embroidery method, we can change the textile's softness, resistance value, and visibility. We try to apply this smart textile to garments. First, we made a garment that can sense body movements. We divided the sensing area with non-conductive sequins, and each group of the conductive sequins can sense independently. The electrical signal generated by the collision of the conductive sequins can control the brightness of the LED on the back of the textile as a way to visualize it. This smart clothing can be based on the LED light change to show the body movement, touch, and the impact of the wind or other external forces on the body. Also, we can use Touch Designer to feed the input data to the computer. We also created a prototype that can recognize the movement of the ankle. Since the sewing thread is elastic, it matches the movement of the textile exactly, capturing the motion of the ankle more accurately. We can change the sequence shape, size, and arrangement to match different functions and different body parts. As for future work, we will summarize the design space of conductive sequin smart textiles and develop an automatic design and manufacturing system. Then we will try more materials and sequin designs to explore more properties. In addition, we will use these properties to explore more embodied applications. Thank you for listening.